Hi everyone. Today I'll be demonstrating a simple yet powerful automation workflow built using N8N, designed to generate unlimited AI images via Telegram commands. The system is triggered by a Telegram bot I created, and it utilizes OpenAI's DALL model to generate images based on user prompts. Once an image is generated, the details, including the user's prompt and Telegram info, are saved to a Google Sheet, and the requester is also notified via email. The goal of this demonstration is to highlight how modular pipelines can streamline AI-powered automation, showing that even complex tasks like image generation and multi-platform communication can be managed through clean, low-code workflows. Let me walk you through a sample run. I'll start by triggering the workflow using a Telegram message. This acts as a self-test to verify that all nodes and data mappings are functioning correctly. In this example, I'm sending a message to the Telegram bot. Generate a picture of 5 coders at their desks. This message is captured by the Telegram trigger node. The prompt is then forwarded to OpenAI's DALL model, where it is parsed and used for image generation. We ensure that the prompt and metadata, like message ID and user details, are properly mapped so we can route the response back to the correct user on Telegram. Additionally, all relevant data, such as the user's name, prompt, timestamp, and generated image URL, are stored in a Google spreadsheet. An email is also sent to the requester with the prompt and a link to the image, making the system useful for real-time use cases or reporting. Now let's move to the actual test run. We activate the workflow in production mode and send the same or slightly modified prompt message via Telegram. It takes approximately 5 to 10 seconds to complete the full process, capturing the prompt, generating the image, storing the data, and sending the email. The image gets delivered via Telegram, and the quality is quite impressive for automated generation. This proves that an entire end-to-end image generation and delivery pipeline can be built using modular tools. Shortly after the confirmation email arrives, the subject contains the requester's Telegram name and the prompt. The body includes a preview or link to the generated image. As an important note, while this entire flow currently runs on the cloud, it can also be hosted and executed locally using N8N's self-hosted setup. Now let me show you how to build this workflow from scratch. We start with the Telegram trigger node. It listens for incoming messages. As a quick test, I'm sending another message. Test image of a fantasy castle. The message payload appears in our node debug output, confirming that the Telegram bot integration is working. With the Telegram node configured, we move on to connecting it with OpenAI's DALL model. The message text is passed as a prompt to the image generation API, and the response is handled by the next steps in the flow, saving the image info to Google Sheets and sending the email notification. Our Telegram node is now configured and working correctly. Next, let's integrate the OpenAI DALL node for image generation. We'll start by mapping the image prompt properly from the Telegram message. Once that's done, we'll trigger a test. After a few seconds of processing, the AI-generated image should be ready. Now let's move on to setting up the Gmail node to notify the requester via email. I'll map the relevant fields. Specifically, the subject line will include the requester's name along with the prompt text. For the body, we'll use a placeholder message for now. Let's go ahead and test it. Note that sometimes it takes a few extra seconds for the email to arrive, so we'll proceed to complete the rest of the workflow and then trigger everything together. Next, we need to send the generated image back to the original Telegram user. For this, we'll add a response node configured for the send photo action in Telegram. To ensure the message reaches the correct user, we map the chat ID, which can be extracted from our initial Telegram trigger node. For the image itself, we can choose to attach it either from the OpenAI node output or from the Gmail node, depending on the use case. To keep things simple for this demo, we'll use the image directly from the OpenAI response. With everything set up, let's do a full test run. We'll reuse the previous prompt with a slight modification. Within a few seconds, the image will be generated, sent via Telegram, and an email confirmation will be delivered. Let's also double-check that the email has been received successfully. This entire automation pipeline can also be self-hosted locally. Once your workflow is running locally, you can expose it to the internet using tools like ngrok or any API gateway solution. This provides a public URL for your local services, making them accessible remotely for testing or integration. I also want to introduce another tool I frequently use for local image generation. You just need to download a pre-trained model and integrate it into your workflow. There are many powerful open-source models available today that offer impressive quality. Personally, I recommend the Flux model over Stable Diffusion for better results. Though keep in mind, it requires a powerful GPU to operate optimally. The broader goal here is to create a locally hosted, AI-driven image generation platform that users can access through Telegram, WhatsApp, or even a custom web application. This platform will interface with your own locally trained models, giving you full control over the prompts, datasets, and output quality. And here's the unique part. Instead of relying on external APIs, we'll use local LLMs like Ollama to refine the prompts. This ensures the pipeline is cost-efficient, secure, and fully under your control with no usage limitations. If you'd like to see more tutorials like this, whether on AI image generation, prompt engineering, or production-ready code workflows, subscribe to the channel and drop a like. I'll be publishing new videos every weekend, walking you through real-world automation and AI development use cases step by step.